Yes, good evening, team. Hello, data explorers. Thank you for joining us for this week's data drill session, which will be on problem solving, communication, report writing, and collaboration, to be led by the incredibly talented Lilian, who is a dedicated senior data scientist with a wealth of experience in the world of banking and financial institutions. Lilian holds a bachelor's degree in computer science from Strathmore University and a master's degree in analytics from the prestigious Georgia Institute of Technology. She brings a unique blend of expertise to the table. Her passion is to empower organizations to unlock the full potential of their data. She is a true advocate for steering organizations towards a data-driven approach, which she does with finesse. Karibu sana Lilian, the virtual floor is yours.
Thanks a lot, Kigo. That was a very good introduction. I feel like I don't know the person you've introduced, but thank you. I think we'll just dive right into the presentation so that we are done by 9 p.m. But ideally, I would want us to be finished by 8:40 so that we can have a few minutes for questions if there are any. I think we'll go through the entire presentation, and then if you have any questions, you can just park them. And at the end of the presentation, you can ask me. So I'll just start the presentation. And ideally, the presentation is on effective problem solving and communication of insights from your data science projects or any other data analysis projects that someone embarks on. So the first part is going to be on effective problem solving, because before you communicate your findings to any stakeholders, you will need to have a problem that you solve. You've done a data science project or a data analysis project, and then now you're communicating your findings or insights to stakeholders. So ideally, problem solving is at the heart of any successful data science project, and it allows data professionals to define and address the right challenges, streamline analysis, and also deliver meaningful insights. This just ensures that you're solving the right problem at the right time and also for the right stakeholders, making sure that you're on the right path and you're not doing something that will not be used. So ideally, having a structured problem-solving approach ensures that data science teams avoid wasted resources, and they also stay aligned with stakeholder goals and develop actionable solutions that create real value, and also solutions that will be adopted by the business and will actually be used. You don't want to be creating solutions or taking a lot of your time doing work that will not be used. So you always need to be aligned with stakeholder goals and also developing solutions that will create real impact and real value. So ultimately, you need to use effective problem solving to turn complex data into clear answers, and also enable data-driven progress and competitive advantage for any organization that you're working in your data science project or data analysis projects. So I have a few steps that ideally I follow when I'm solving any data science project, and we'll just go through those different steps one by one. So the first step is to frame the problem with a broad perspective. And this just means that you're not looking at it narrowly or just defining the problem in one sentence and leaving it at that. You're looking at the problem in a broader perspective. And this just means that you clearly define the objective in business terms. So you sit down with business teams and you define the objective in their business terms. So you're not defining in technical terms, which is more easier for data analysts and data scientists, but you're looking at it from the business perspective so that you ensure you stay aligned with the goals that the business requires. Because at the end of the day, the solutions we are creating are not for data scientists or for the technical team, but it is for the business. And therefore, we need to make sure that the objectives we are fulfilling here are for the business. Secondly, you also need to understand how the solution will be used and identify whether there are any current solutions or workarounds that are being used. Sometimes you'll find that users are coming to you and they already have sort of a solution that they're using. Maybe it's manual, maybe the accuracy is not very high. So they're asking you to refine it a bit better. So you need to understand, how is this solution going to be used? Is it going to be a web system where they're going to be inputting values and getting feedback, or you just need to understand how do they want the solution to look like. Then you also need to know whether there are any solutions that are existing so that you see how you can use this information to create the solution that you're working on. Then you also need to determine the appropriate problem framing. And this just means looking at, is it a supervised problem? Is it an unsupervised problem? And therefore, you'll be able to understand what are the different models, what are the different algorithms and machine learning models I can use to solve the problem. Then we also need to establish the performance metric that align with the business objective and define the minimum acceptable performance. For any problem, you need to have a performance metric. Therefore, you will see whether the solution you've come up with is acceptable to business or not. If you cannot measure anything, then ideally you're not able to really see how much value you're bringing in. So you need to have a metric that can measure how good your system is. Then you also need to consider any similar problems that are already existing so that you can leverage on existing tools or expertise. So you can ask around in your team whether there are any similar problems, or even look around on the net. Are there any similar problems that have been solved? And how can you leverage this expertise that has already been put out there so that you're not really repeating yourself or trying to rebuild the wheel? Lastly, you need to validate assumptions and identify the available resources. And here, assumptions just mean that you might have certain assumptions about the business problem, but you haven't validated it with the business. Therefore, if you have any assumptions, you need to validate with the business whether these assumptions are actually correct or incorrect, so that when you're using these assumptions in your solution, you're making sure that it's actually an assumption that is correct. The next step is to acquire the data. So when you acquire the data, you need to make certain considerations. And the first one here is you just need to list down the data needed. So you can have several tables that you require, or even data from disparate sources. So you need to list all of this, and then you need to see how can we aggregate and integrate these data sources so we can have one unified data set that we can use to solve our problem. So you document these sources, and then you also assess your space requirements, because for any solution, you need to see whether you actually have space requirements for this data. Because at the end of the day, if you do not, then you might need to try and see, is there any other solutions that we can use that does not require as much space requirements as the one that we have currently. Then secondly, you need to ensure that legal obligations are met and you obtain required authorizations. There are some data sets that are a bit sensitive to acquire that you might need for your analysis, and therefore you need to make sure that you're always aligned with the legal obligations for any data sets that you're using. And also if you require any authorizations to access certain data sets, even within your organization, you might find that there are some data sets which are meant for only a certain department. Therefore, you need to acquire the required authorizations so that when you're starting your project, you're not running around trying to get those authorizations so that you can get the data. Number three, you need to access and transform data to a workable format while protecting sensitive information. And sensitive information here just means, I think, personal identifiable data, which is something that I think was brought in last year in terms of data protection, just making sure that data that can identify a person is not just out there. So you need to ensure that you're protecting sensitive information of the data that you're accessing. And also once you have all your data sets in one unified format, then you can now start transforming it into a workable format that you can use for your solution. Then lastly, you need to set aside a test set. This is if you're working on a machine learning solution. Therefore, you need to set aside a test set so that you avoid data snooping. And data snooping here just means creating inferences from your data set after you have already looked at it. So you have looked at the data set and then now you're coming up with inferences. That's data snooping. And also ensuring that you have an unbiased evaluation. So you need to have a test set so that also you can make sure that your machine learning model generalizes well. And ideally also you avoid data snooping and ensure that you have an unbiased evaluation of your data. Then we move on to step, okay, I don't know. Oh, sorry, I interchanged them. So we'll move on to step 3. And here we are just exploring the data. So we have collected data from different sources. We've transformed it into a workable format. And now we are exploring our data so that we can understand it a bit more. So the ideal way of trying to explore your data would be on Jupyter Notebook. And you can also document your findings, because on Jupyter Notebook, you're able to use Markdown cells to just document your findings and comments. So you create a working copy for exploration so that you don't tamper with the original copy of your training data set. So that when you're exploring your data and if you make any changes to that data set that you ideally wouldn't want, you can always get the original data set. That's why here we are saying make a working copy for exploration and you use Jupyter Notebook to document your findings. Secondly, you examine each attribute to try and understand what are the types of the different attributes we have. Do we have any missing values? Do we have any noise in our data set? Do we have outliers? What are the distributions for the different attributes we have in our data set? And also, what is the distribution of our entire data set? So it's just looking at each attribute by itself and also just trying to understand the correlations between different attributes. That is looking at each attribute by itself. Then we visualize data to gain insights and determine promising transformation. So visualization here is just trying to understand the different interactions between attributes. And also here is where you'll be able to see if there are any promising transformations that you can make to your data set that will be useful to model building. So you can interact different variables to come up with new variables, or you can even decompose different variables. Say for a date variable, you can decompose it to create the month, the quarter, the year, the week. So you can decompose different variables to create new variables that can be very useful for your machine learning models. Then we also identify target variables for supervised tasks and explore correlations. So for any supervised task, we'll need to identify the target variable, and we'll also just want to understand the correlations between the target variable and the different attributes and see, do we have high correlations? Do we have no correlations at all? Or do we have negative correlations? And that will impact your analysis. And you might even find if there are no correlations at all, does that data really tell you, does it give you a picture of what the target variable is doing here? Because if there's no correlation, then there might be something that's off. Lastly, you can document your learnings and identify any additional useful data. So once you've done your exploration, you might realize that there are some additional useful data that you can get, and you can always consult with a business team to try and understand, is there any more additional data that I can use and I can augment with the data that I have so that I get a better model. Step number 4 is to prepare the data. So we've already explored our data. We understand it a bit better. Now we are preparing our data, say for machine learning, modeling, or for anything else you might want to do. And the first thing most times you will do is to clean your data. And this just means that you're handling outliers. So are there any outliers in your data set? Are they real outliers or are they errors? If they are errors, then do you want to drop them or do you want to fix them? Do you want to fill them with zeros if it's numerical values? Do you want to fill them with a mean, a median, or if it's for a categorical value, do you want to fill it with a mode? So it just depends with how much data you have and what you think is the best way to actually handle outliers and also missing values. So you'll also consult with the business team to understand what is the best way to handle these values. Then number two, you can perform feature selection, and this is optional. Sometimes you might have a data set with a lot of features, and you might find that there are some attributes that provide the same information with other attributes, or attributes that don't provide any useful information. So ideally, you just have a huge data set that's not helping you. So you might perform feature selection so that you remain only with the attributes that are adding value to your analysis. This is an optional step. You can skip it if you feel like the features that you have in your data set are all useful. Then we move on to engineering new features. And this is when you feel like maybe the features you have are not enough, or after doing your exploration, you see that there are some more features you can create from your data set that will be very useful for your analysis. And creating new features can just mean decomposing your features, as mentioned earlier. This just means almost breaking down your features, like date, creating new features of month, quarter, year, week, or also doing other promising transformations, like say the square root of a feature or the log transformation of a feature. And finally, you can also aggregate features to create promising new features. And aggregating is just means interacting two features to come up with another feature. So this is also an optional step. I don't think it has to be done, but if you feel like it's necessary, then you can do it here. Or sometimes you'll find that you'll move on to even picking a model. And then now when you're fine tuning your model, you can figure out maybe if I was to create new features, the performance of my model will improve. Then you will come back to this and you will create new features and see whether your model performance actually improves or not. Then the last one is scaling features for standardization or normalization to improve model performance. And this just means that sometimes you'll have features which are on different scales, and this might affect the performance of your models. Certain models perform well, even if the features are on different scales, but certain models don't. Therefore, you might need to do standardization or normalization to ensure that your model performance is not degraded because the features are on different scales. Then step 5, now you move on to shortlisting promising models. And this is with the assumption that we are doing a data science project. So once you've done all that, you can train multiple models with diverse methods. So you always start, most times you start with very simple models, because sometimes a simple model can actually give you the best performance. So you can start with linear models, and then you can also now use ensemble learning and then neural networks. So you can just try multiple models, and then you compare the performance using cross-validation. Then you analyze the errors and feature significance. Then lastly, you select the top 3 or 5 models that make different types of errors for further tuning. So this just means that you've come up with different models, you've trained them, you've checked their model performance, you've picked the top, and now you want to further fine-tune these models so that you can pick the best performing models. So we move on to step 6, and this is where you fine-tune the model. So you optimize your hyperparameters. So if your model has hyperparameters, you optimize them using cross-validation. And then also for the data transformation choices. So say for filling in missing values, you can choose to treat it as hyperparameters, and you try and use different imputation techniques and see whether they'll improve your model performance. So maybe you had filled in the missing values with 0. Then you can try and see okay, what is the performance when we have the missing data filled in as 0? Then you change it to a mean. Then you check how is the model performance. Then you change it to a median. And ideally, you finally pick the one that performs the best. Just as a recommendation, unless there are very few hyperparameters values to explore, a random search is preferred over the grid search. So that's just something you can keep in mind. Then when you're also fine-tuning your models, it's important to try ensemble methods, because when you combine your best models, they will often produce better performance than running them individually. So this is something you can explore when you're just fine-tuning the model. And once you're confident about your final model, then you measure its performance on the test set to estimate the generalization error. And the generalization error here is just what is the error on the test set. So this is data that's completely unseen to our model. So how does it perform? So we just have a warning here that you shouldn't tweak your model after measuring the generalization error, because you will just start overfitting the test set. Because this means that you're now learning the characteristics of the data in the test set, and you're not really generalizing well. So you shouldn't tweak your model based on the generalization error. You tweak it based on the error you get on the training set or on the cross-validation set. So lastly, we assume that you've gone through the entire process and the solution passes the performance metrics that you had set. Therefore, it's acceptable to the business. Now you need to present your solution. And this is where now communicating your insights effectively comes in. So I will not even go through this slide. I'll just move on now to communication of insights effectively. So for communication of insights and results, data analysis is a very technical field, and sometimes we might be cheated to think that technical expertise is the only important skill you require. However, that's not true. Communication skills are extremely important in this field, because it's not just about number crunching. It's also about impactful results and how you present it. When you present your findings and your audiences or your business users don't understand it, it's very unlikely for them to use that solution or to even trust on and act on that data. So you need to be able to communicate your insights in a very clear and credible way. And you need to also hone the skill of data storytelling, because data storytelling is the one that bridges the gap between your number crunching as a data analyst or a data scientist, and it connects now to decision makers so that you can help them make informed decisions that are data driven. Decisions, a lot of decisions before the invent of data analysis and data science were just made on gut and also knowledge, expert knowledge. But now with data, we are able to make more informed decisions that are data driven. But if you are not able to tell your story very well, then people are not very likely to trust you. So I'm going to present some strategies that can be used to communicate your insights to stakeholders effectively, that ensures your solutions and results achieve maximum impact and also adoption. So the first one is knowing your audience. And this means therefore tailoring your message for each different audience. Not all stakeholders are the same. So it's very essential for you to understand, who am I presenting this solution to? And once you understand it, you're able to tailor your message for that particular audience. Before sharing your insights to any audience, you need to understand several things. And the first one here is just their data literacy. So you need to gauge how familiar are they with the data language or even the data that you're presenting to them. You'll find that, say, for someone who does operation on a day-to-day, they might understand the data better. But if you're speaking to the executive leaders, then they might not really understand the intricacies of the data, but for them, they only care about strategy and how the solution that you're giving them will help them in terms of creating the right strategy for the organization or for the department that they are working in. Then you also need to understand their interests. You need to identify what matters most to them in the results that you're presenting. They will be very different for different team members. For executive leaders, it will be very different as compared to for your business user who their day-to-day job is operational. So you need to understand the interests. And lastly, you also need to understand the goals. What is the objective of your insights to these stakeholders' goals, and how can you support them? So you need to tailor your message with the goals of the stakeholder at the back of your mind, so that they are able to be convinced to actually accept your solution and that it's actually helping them achieve the goals they have. Lastly, effective data communicators adjust the language, tone, and format, and the level of detail to resonate with each unique audience. You cannot go to executive leadership and you're using technical terms when you're doing your presentation. So you need to come to their level and use a language that they understand. And it's very important to also collaborate a lot with the business team, because there are certain languages they use and they can be able to help you come up with very good presentations using the language that they understand. Secondly, you need to choose the right format for communication. There are very many different ways you can do your presentation, and I'm going to list here 5 of them and give you the advantages of these different 5 formats of communication. So selecting the right format for presenting your data analysis is very crucial in ensuring your message is well received and understood. And each format presented here has unique strengths, and it depends on your audience's needs. It does not mean that one format is better than the other. It just depends that it can be better for one audience as compared to another. And the first one here is written reports. So written reports are very comprehensive and very detailed. So they go into very in-depth understanding of the data analysis process, methodologies used, results, and also recommendations. They also are very clear and consistent, and because of the longevity of the reports, they explain any jargon that has been used, therefore ensuring clarity. And it's very ideal for stakeholders who need an in-depth understanding of the data analysis process. So for this one, it's mostly for people who are a bit technical. They don't really have to be in the data science team, but in the business, you can find people who are a bit data savvy and more technical. And an example would be marketing teams. You'd find that marketing teams understand data very well. They'll tell you about click-through rates. They'll tell you about return on investment. So for them, they will want to understand a very detailed a detailed understanding of the data analysis process. Then we have slide decks. And slide decks are very visually appealing, and it's similar to what I'm using right now. So it's very visually appealing, and it has graphics and also presents key points. So for this one, it's different from written reports because this one is just key points, and it also makes the content engaging. So for slide decks, you can also incorporate hyperlinks, and people can click and be able to interact with your deck a bit more. Then it has summarized content, and therefore it's suitable for stakeholders who prefer a more visual and summarized presentation. So it's quite good for top management and executive leaders. Then we move on to dashboards. And dashboards are very good because it offers dynamic interaction and customization. It allows stakeholders to filter and explore data in real time. This therefore means stakeholders can explore and filter the data according to their specific needs. And even if they have several questions, they can actually answer these questions from the same dashboard by just using different filters. And then it also has time-based monitoring because it's very excellent for tracking metrics over time. Then we move on to videos and webinars. And this one is very good because it's engaging. It combines visual and narration, and therefore it creates a very captivating experience. And because it's a video, it gives sort of a personal connection because it adds a bit of a relatable human element. And lastly, it has replayability. With videos, the same way we are recording this, if you want to come back and listen to it, you can always replay it. And therefore, it's a very good tool that can be used and can be accessed in future. And lastly, we have infographics. And this is just a quick visual summary. And it's great for giving stakeholders who need a fast visual snapshot. So this can be, let's say you're launching a new product, you can just create an infographic about the new product, what are the advantages, what are you trying to sell. So it just gives a fast visual snapshot of what you're trying to present. And then they're very easy to be shared, and they can be shared across different platforms. So you can share it on emails, you can share it on Teams, and they're ideal for broad audiences. Then number 3, you need to use clear and simple language. So here we are just saying that when you're presenting your data, you need to prioritize clarity and simplicity. You don't need to use a lot of technical jargon. It's already very clear that you're quite smart and you've done a very good data analysis or a data science project. Therefore, you don't need to use a lot of technical jargon because you will lose people. And also using acronyms. This is something that you need to avoid. If you go around using acronyms, people are lost, and even sometimes meaning is lost because someone might figure out, okay, what's the meaning of that acronym? And then they might eventually come up with a meaning that is not what you meant for. So you need to make sure that you're not confusing your audience by using jargons or acronyms. So you need to take your time to define any complex terms that are in any of your presentations. Things to remember here is to be concise. So use active, straightforward sentences to state key facts without adding unnecessary detail. Then you also need to maintain consistency and objectivity. So you need to opt for plain, consistent language to express meaning clearly and also objectively. And then finally, you need to guide with transitions. People need to understand when you're moving on to a different topic. So use signposts and transitions to smoothly guide your audience through the analysis so that you don't leave anyone, you're moving together. Then you also need to follow a logical flow with clear language, therefore ensuring that everyone can easily understand the results and the implications of your data analysis. And when people understand the results and implications of your data analysis, it becomes very easy for them to trust you and to actually adopt the solution. Then number 4 is visualization of your data for impact. Data visualization is more than just presenting numbers. Data visualization brings your data to life. It makes complex information accessible, engaging, and actionable. And there are several strategies that you can always follow when you're doing your visualizations. The first one here is you can use bar charts, and they're very ideal when you're comparing categories. It brings out a very clear picture of how different categories are comparing and how they are performing, which one is the better category, which one is the one that's lagging behind. and what actions need to be taken. Then we have line charts, and these ones are perfect for showing trends over time, and it gives you a very good overview of different peaks and dips in your data sets, and you're able to interrogate your data a bit more to understand what are the peaks, what are the dips, and what caused those peaks or dips in your data sets. Then we have heat maps, and these are very important or ideal for understanding concentration and density. Then we move on to pie charts. Pie charts are quite similar to bar charts, but pie charts are better for few categories, and they're ideal for showing proportions among few categories so that you're not confusing the different proportions, especially if you have too many categories, then it becomes an issue in terms of interpretability and readability. Then lastly, we have scatter plots, and scatter plots are very nice when you're trying to identify relationships in your data. Then number 5 is to always remember to tell a compelling story with your data. And here it just means to tell a story that will give you credibility and will earn trust with your stakeholders. So you need to engage your stakeholders by weaving a narrative that resonates with their interests and emotions. And telling a story with your data goes beyond presenting statistics. As mentioned earlier, it creates a persuasive and cohesive tale that connects insights to what matters most to your stakeholders in terms of interests or goals. So you need to always remember this when you're presenting your insights. Some of the tips in creating a logical narrative is to identify the problem or the question, and you should always start with a clear problem or question to capture their attention and give purpose to the data. So when you're presenting your findings, you need to be able to say, this is the problem that we were trying to solve. So that even as you're moving through your presentation, you're sort of carrying them along and trying to convince them. You see that problem we talked about, this is how we solved it, and this is how we can prove to you that this solution actually works. Then you need to demonstrate your solutions. Present methods, results, and recommendations that address the problem, creating a logical and engaging flow. And when you're demonstrating your solutions, you need to show. Don't just say it, but also show. Give evidence. This is why the solution actually works. And this is why the solution is even better as compared to what you're using before. And then you need to emphasize on the benefits. Show how the findings align with audience goals and highlight their benefits, making data relevant and impactful. If someone does not find value in the solution that you're giving to them, they're not going to use it. So you need to emphasize the benefits while still connecting to the business question that you're given. So a strong data story ensures your insights resonate and drive meaningful action. Then lastly is to keep the business question center of all data analysis. So aligning your analysis with the core business question is crucial for delivering insights that truly resonate with stakeholders. By consistently connecting your work back to the problem at hand, you ensure relevance and drive actionable outcomes. And there are some guidelines that you can always use for a centered analysis, whereby the business question is always at the center of your data analysis or your data science project. And the first one here is start with the why. You need to define the core business question or the problem before starting your analysis. And I think I've said it enough during this presentation that it's very important to understand what is the problem that I am solving, and it needs to be from the business side, not from the way the data scientist or the data analyst see it, but how does the business team see this problem? So that when you're solving the problem, you're not solving it for yourself, but rather you're solving it for the business. Then you need to align the analysis with the goals. You need to connect the dots. For every step from the data connection to modeling should directly address the business question. Understand the goals, and during your analysis, you should always remember what are the goals, and therefore your analysis should always align with the goals. Then you need to visualize with purpose. Show, don't just tell. So choose visualization techniques that are aligned with the business questions. Charts and graphs should tell a clear, compelling story that directly addresses the problem at hand. Then create actionable insights. After doing your analysis, you need to turn your findings into practical recommendations that address the business question. It shouldn't just end at analysis or the findings that you have found. How can it be turned into recommendations or solutions that can be used on a day-to-day basis by the business? Then second last, you need to communicate with empathy. And this just means that you use language and examples that stakeholders understand. Therefore, don't use languages that they might not understand, because at the end of the day, they will not buy into something that they don't fully understand or trust. And lastly, you need to evaluate and iterate. So you need to continuously review and refine analysis to stay aligned with changing business needs. So even when you're doing your analysis, sometimes business will come back to you and tell you, we've rethought this and we think that you need to add this into the analysis. So you need to continuously review, even with the business, even if they haven't come to you, you always need to touch base so that if there are any changing business needs, you're always in the know. So by the time you're finishing your analysis, you don't want to finish and then you're being told, oh, the needs changed during your analysis. Therefore, the solution doesn't work for us. So you always need to evaluate and iterate and touch base with the business. And that is it. So I will welcome any questions.
So yeah, thank you, Lilian. That's really insightful, and personally, I've learned a lot. And thank you for taking time to present to us and educate us. So I had a question on the warning that we had, I think, in the previous slides about once you have trained the model and you have subjected to your test, or you have subjected your test to your model, I would like for you to emphasize on why you should not try to improve on the model after subjecting it to the test, or after subjecting test to the model. Thank you. I don't know if that is clear.
Thank you, Sam. That's pretty clear. So the warning there is just if you tweak your model based on the performance of your test set, then you might start overfitting your model. And overfitting here means that you're learning the characteristics of the data as compared to the general characteristics. So ideally, your model will perform well on the test set, but if you're to put it into production and your model gets data that it has not seen before, it will not perform very well because it did not generalize well. I don't know if that answers your question.
Yeah, so does it mean any improvement that you want to make will be on the train set?
So the improvement would be on the training set, and for the training set, I think the recommendation here is to have also a validation set. So you have a training set and a validation set. So the validation set is the one that will help you improve your model. And once you have improved your model based on the validation set, then you can use it on the test set so that you are avoiding overfitting. So you'll have your training set, you have a validation set, and then you have a test set. So you look at the performance of your validation set. And if you're not very satisfied on how your model is performing on the validation set, then you will tweak your model a bit further before you now test your model on a test set.
Thank you. That is perfectly clear.